Okay, today is December 5th. And we are adding and subtracting fractions today. Of course, they're rational fractional expressions, but it's the same concept from what you learned back in, like 4th or 5th grade, maybe? Adding fractions? Okay. So I have a 4th or 5th grade problem here. Because the ideas are the same. But before I get into that, I do want to mention that we have one more day of notes. That'll be tomorrow. And then you have a review on Monday and Tuesday and a test on Wednesday. Then we review for finals Thursday, Friday, Monday, and Tuesday. And you guys have your finals on that following Wednesday and Thursday. So know that there's not much left here. And you should also know that this last test, which is on all this stuff with fractions, you won't be able to do test corrections on. So you will have one more test correction opportunity, and then that one you won't get one because there's just not enough time. And obviously the final exam, there are no test corrections on the final exam, okay? So keep that in mind. There's not a lot of time left. You should also know that on the board it says the last day to submit any work to me is December 13th. That's next Friday. If you have makeup work or missing CPs that you want to turn in to me, it needs to be done before Friday. I will not accept anything after Friday. The 13th. Except for the extra credit review. So the one thing that you can turn in to me is your extra credit review, which you'll get next week, and it'll be due at the time of the final. Okay? All right, so here we go. What do you need in order to add or subtract fractions? Common denominators, yes. So I'm glad you know that you need common denominators. So this first one's pretty easy, but I want to do it the same way that we're going to do the work today. And that is, I had a rule of thumb that we were using all week long. What was my phrase of the week? Factor first, factor first. And we want to do the very same thing we have been doing, which is a lot of factoring. When we're adding and subtracting fractions, we want to factor the denominators. So I want to look at this denominator 7. Hey, what are the factors of 7? 7 and 1. It's prime. That's it. 7 is the only factor we've got. And then what about the factors of 14? 7 times 2. Very good. So we can write it in factored form, and actually writing it in factored form is kind of nice because then you can look and say, hey, now we need a common denominator. And to get a common denominator, the easy thing to do is look for what they already have in common. What factors do they already have in common? Yeah, they already have this great 7 here. And now we just need to make all the denominators match. So we look for what they have in common, and I say, hey, there's an extra 2 over here. So this side also needs that 2. So I'm going to multiply by 2 so that we get the same factors in the denominator. Can I just multiply the denominator by 2? No, you have to multiply the numerator by 2 as well. How come I have to multiply top and bottom by 2? Yeah, if you just do the denominator, we've changed the value of the fraction. It becomes 5 over 14. When we're multiplying top and bottom by that same factor, 2 divided by 2 is essentially 1. 2 goes into itself 1 time. So we're really just multiplying by 1, and we're creating an equivalent fraction, not changing the value. This, we get to multiply together. It becomes 10 over 14 minus 3 over 14. And what is 10 over 14 minus 3 over 14? 7/14. And 7/14 happens to reduce and become what? 1/2. So sometimes we can reduce as well. And I'm very glad that 10/14 minus 3/14 is 7/14 and not just 7. Like, that's a lot of people, the denominator does not disappear, does it? No, it stays. It's there for good. Okay. So the same thing happens when we have a problem like this, which is more in line with what we are doing today, because we have rational expressions instead of just fractions. And so I want to do the same sort of thing. X is its own little factor. 2x is really 2 times x. So there's 2 factors that multiply together. And we are going to get a common denominator. What do they have in common already? They both already have an x. So what do we need to do? Multiply by 2 on the other side. Yeah, we need this little 2 to match up as well. So I'm going to multiply top and bottom by 2. And now our denominators match. I can multiply my numerator together. 2 times 5 is 10. We have a 2x in the denominator and 3 over 2x. What is 10 over 2x minus 3 over 2x? 7 over 2x. Okay. All right, ladies and gentlemen, factor first is still the phrase of the week. You must look to factor. So here we go. Step 1, simplify the expression. Seven over 5x plus 3 over 3x squared. Seven over 5x plus 3 over 3x squared. Again, what are my phrase of the week? Factor first. All right, factor first. We want to look at those denominators in factored form. And then we need a common denominator whenever we're adding or subtracting fractions. Common denominator, common denom. Okay, so this 7 over 5x plus 3 over 3x squared, it's not like I can double bubble these. Instead, 5x, 5 times x, those are the factors. The things that multiply together to give me that denominator. What can I do with the 3x squared? What are those factors? Three times x times x. X squared is x times x. So I'm just writing them out. There are lots of shortcut ways to do this, but I like to write it out because it's easier to see what they have in common. So these are our denominator factors. What do they have in common? They each have an x. So there's a factor in common. They each have an x. Now we need to make the denominators match. So what does this first fraction, what's missing? What does it need? It's got to have a little bit of everything. So what else does this need? Another x. Sure, this fraction has an extra x. So we need an extra x on top and bottom on my first fraction. What else does this first fraction need? A 3. Yeah, there's an extra 3 over here. I need that same 3 multiplied on top and bottom as well. Everything has to have the same parts. What is my second fraction missing? A 5. Yeah, we've got a 5 on the first fraction. I need the 5 on the second fraction as well. And so when I look at those denominators, I can see that I've got a couple of x's, I've got 3's, and I've got 5's, and everything matches. They're made up of all the same parts. Okay? Might be in a different order, but that's okay. That doesn't matter. So my denominator now, since everything matches, I only have to write one denominator, which is kind of nice. And that denominator is 3 times 5 times x times x. My numerators, we're going to clean up. We've got to multiply my numerators together. Multiply 3 times x times 7. What do you get? 21x. Good. There's a big plus sign. And then I got to multiply 3 times 5 to get 15. That's the basics of getting a common denominator. Okay? If we could combine like terms, we would need to combine like terms, which we'll do in the next one. But you always need to check to see if you can simplify this fraction. Is there a greatest common factor here? 3, yeah, there's a GCF of 3. So I'm going to take out the 3. If I take out the 3, what's left behind? 7x plus 5. All right. And now my denominator, you'll notice I have the 3 times the 5 times the x times the x. Does something reduce? The 3's, absolutely. I have a 3 on top and the 3 on the bottom. 3 goes into 3 one time. So I'm left with 7x plus 5 over 5x squared. And this is the final reduced answer. Okay, letter B is probably the most difficult one of the day, but what's the phrase of the week here? Factor first, factor first. We want to factor denominators if we can. So I have x squared plus 4x plus 3. Can I factor that? What can I do with that? Double bubble. Yeah, I'm going to rewrite that so that it's in factored form. X times x is x squared. What times what is positive 3? Positive 3 and positive 1. So I'm just going to cross that out and pretend that this was how it was originally written. All right. And then I have that other denominator here. What can we do with x squared minus 9? Double bubble. It double bubbles. How does it double bubble? X plus 3, x minus 3. Very good. So again, we need to factor those denominators first. And then we want to get a common denominator. So I'm going to ask, what do they already have in common? They both already have this x plus 3 factor. Good. Now we need to make them have all the same parts. What does this first fraction need? X minus 3. Yeah, we've got this bubble over here. I need that same bubble, x minus 3, on my left. Top and bottom. X minus 3, top and bottom. The green pen is totally dying. All right. What about my second fraction? What does this second fraction need? Yeah, we've got this extra bubble, x plus 1. I need the x plus 1, top and bottom. Now we can see that both of these fractions have a green part, a pink part, and a purple part. They got all the same parts. So I can multiply, well, I'm going to have since my denominator is common, I have one common denominator. It's a nice thing. Once you get it to match, you only have to write it one time. What do we need to do in our numerators? What do I need to do with this x minus 3 and the x minus 1? You have to multiply. These is a bubble times a bubble. We have to multiply this whole thing together. What does that require us doing? Distribute. Yeah, lots of distributing here. We have to distribute. X times x is x squared. X times -1 is -1x. -3 times x, -3x. And -3 times -1 is +3. Lots of distributing. Then we have a giant plus sign. And what do I have to do with this second numerator? Distribute the x. Yes, we have to distribute the x. X times x is x squared. X times 1 is 1x. So you do have to multiply all the numerators together. My one common denominator. What do you suppose I need to do with my numerator now? Combine like terms, yes. 1x squared plus 1x squared is 2x squared. Good. I have a -1x and a -3x and a +1x, which is what? -3x. And then I have my +3. It's always a good idea to double check to see if you can look for a greatest common factor or double bubble. This doesn't double bubble, but you always want to see if you can factor and reduce just to make sure it's in lowest terms. We like to reduce everything. This one does not do that. Questions on either of those right now? And just like say, there's one more day of notes tomorrow. Letter C. X over x squared plus 6x plus 9 minus 1 over x squared minus 9. What do you need to do first? What's the phrase of the week? Factor first. So we're going to take our denominators and we're going to rewrite them in factors. How does x squared plus 6x plus 9 factor? X times x is x squared. What times what is +9? +3 times +3, sure. So rewriting that denominator so it's in factored form. What can we do with x squared minus 9? How does it factor? X plus 3, x minus 3. Yeah. So again, rewriting those denominators so that they are factors, bubbles. So then we can ask ourselves, hey, which factors do they have in common? What do they have in common? X plus 3. They both have an x plus 3. What does this first fraction need? What is it missing? X minus 3. Yeah, this one has an x minus 3, so I need one over here as well. We need an x minus 3 on top and bottom. All right. What does my second fraction need? Another x plus 3. We have this extra x plus 3. We got to get that one on there too. So I'm going to multiply x plus 3 on top and bottom. Now, since everything matches, we got a blue factor, a pink factor, and a red factor. We got all those factors matched up. We can write a common denominator. Just a single common denominator. Instead of having two separate fractions, they get combined into one. What do I have to do with this first numerator? X times the x minus 3. What do we need to do? Distribute. Yes, it's x times x. X times x is x squared. X times negative 3 is negative 3x. You need to distribute. It is a product. You got to multiply everything. Now, here's the tricky part. This is subtraction. What do we need to do with this second numerator? We're going to distribute. Well, the question is, what do we distribute? A negative 1. Very good. We need to distribute the negative. And that's the hardest part about subtracting fractions, is remembering to distribute your negative. So we're going to think about it as a negative 1 times x, which is negative x, and a negative 1 times 3, which is negative 3. So make sure you distribute your negative on those subtraction problems. And then we can just combine like terms. X squared, negative 3x, and a negative x is negative 4x minus 3. And this is a great answer. I want to always check, is there a greatest common factor in the numerator? Can I double bubble and reduce some stuff? But this numerator does not double bubble, so you can't reduce anything. Okay, the last one, letter D, 5x minus 1 over x squared plus 2x minus 8 minus x over x plus 4. What do we need to do first? Factor first. And take my denominator and factor it. X times x is x squared. What times what is negative 8? Good. We're going to take a positive 4 and a negative 2. So rewrite that as bubbles. Can I double bubble this x plus 4? No. It's x to the first power, so it's already its own little bubble. It's prime, so to speak. Can't do anything with that. So now we can look and say, hey, what bubbles do they have in common? They both have that x plus 4 in common already. So what do we need to do? Do I need to put something on this first fraction? Does that go in the first one or the second one? The second one, yes. We're going to multiply by x minus 2 so that they both have an x minus 2. So I've got to put it on top and bottom. Now that our denominator matches, I can write a single denominator, the single common denominator. And my numerator is going to be made up of 5x minus 1. What do I have to do with this negative? Okay. Negative x. Yes, we're going to distribute the negative x. So negative x times x is negative x squared. Negative x times negative 2 is positive 2. And then we just need to combine like terms in the numerator. So I have a negative x squared. I have a positive 5x. Yeah. Oh, it's supposed to, thank you, it's 2x, isn't it? Yeah, thank you, thank you. Let's fix that. Thank you, thank you. 5x plus 2x should be 7x's. And then we have our negative 1. And again, always a good idea to double check and see if I can take out a greatest common factor or double bubble. That definitely does not double bubble. Do you guys have questions for me? Watch those negatives. Number 1, I did on the board for the worksheet today. You have class practice 80.